Hello student, how are you? I hope you all are happy, healthy and fine at home. So what did we discuss yesterday? Yesterday we discussed about the hydrogenation reaction. If you treat that alkyne with molecular hydrogen in presence of catalyst like H2 in presence of nickel or platinum or palladium, two molecules get consumed and we are getting the formation of the alkane. But by using as a special condition, we can stop the reaction at first stage, giving the alkene. Suppose let us see as a 2-butene, and then we are using as a Lindlar catalyst. Lindlar catalyst specifically prepared in a palladium, and we are getting as a cis-alkene. And as we know that cis-alkene means what? Both the similar group are on the same side of the carbon-carbon double bond is termed as a cis isomer, and trans isomer if you treat the same substrate with dissolved sodium in presence of liquid ammonia or lithium in presence of liquid ammonia, the resulting compound formation of the alkene should be the trans in nature. And trans isomer, as we know that the trans isomer similar group are on the opposite side of the carbon-carbon double bond is termed as a trans isomer. And this way we have learned, and today we are going to learn that because we are talking about the that chapter number 4, the name of that chapter is the reaction of unsaturated hydrocarbons and the carbon oxygen double bond. Now the unsaturated means what? Organic compound. Theoretically I am talking, theoretically the organic compound containing carbon-carbon double bond or the multiple bond, maybe as a triple bond. So that type of the compound are called as the unsaturated hydrocarbons. And as we know that hydrocarbon means what? The organic compound which is made by carbon and hydrogen are known as hydrocarbons. So simple. And we are learning here the reaction of carbon-carbon triple bonds are there, and so far we have seen some of the reaction. Today we are going to discuss about the addition of water, which is known as hydration. Addition of water, and the way this addition of water similar to as alkyne, this reaction also has a electrophilic addition reaction, and that water get added across the carbon-carbon double bond, but in presence of the sulfuric acid and HgSO4. HgSO4 means mercuric sulfate. It is act as a that along with that it is used so that we will get the resulting compound is a aldehyde, and the resulting compound, the addition reaction takes place according to as a Markovnikov's rule. And as we know that Markovnikov's rule means what? In an addition reaction, negative part of the addendum attached to those carbon atom which carries the less number of hydrogen atom. But if you see the simplest example, that is acetylene over there, and the end you will end up with the product obtained or the yield obtained over here, product obtained is the aldehyde or the ketone. Only acetylene treated with the water in presence of H2SO4 and HgSO4 gives the acetaldehyde, and rest of the alkyne gives the ketone. When only one molecule, and which is acetylene, gives the acetaldehyde, whereas rest of the alkyne gives or produce the ketone. So that are the thing you have to keep in mind. Let us see the example over there, how we are getting here the example. For example, suppose we have this one H C triple bond C. The example is acetylene, right? The example is acetylene. This is the simplest example and which is a symmetrical one, and it is treated with here H2 water in presence of H2SO4 sulfuric acid and the HgSO4 mercuric sulfate. The resulting compound is formed is this one CH3 C double bond OH. This is acetaldehyde, right? The name of this compound is acetaldehyde, and now this is the common name of this compound, acetaldehyde. And can you tell me the IUPACS name of this compound? Yes, what is the IUPACS name of this compound? The IUPACS name of this compound is ethanol. Last suffix al indicate as a aldehyde group is there. Only this acetylene or this acetylene is a common name. Can you tell me the IUPACS name of this compound? The IUPACS name of this compound is ethanine. YN suffix indicate as there will be a carbon-carbon triple bond is there. So that is the IUPACS name. And after the had this, and when water is added across the carbon-carbon triple bond and the resulting compound, and that process is known as a hydration. Addition of water across the unsaturated carbon-carbon double bond, that process is known as a hydration, means addition of water get over there. Now let us look at as a mechanism, how the mechanism takes place over here. See here H, then triple bond CH, then as we know that H and OH, and according to as here, as we know that this water molecule, this hydrogen atom has plus delta charge, OH can get the minus delta charge, and this double bond, what is happening, this is act as a nucleophile and this act as a electrophilic in nature. This is a nucleophilic in nature and this is a electrophilic in nature. The reagent is a electrophilic in nature, and that's why that addition reaction is known as electrophilic addition reaction. That's so simple. Now what is going to happen? And as we know that water flows from higher level to lower level, so this double bond when shifted, forming the bond with this hydrogen atom, at the same time this hydroxy group is attacking on this carbon atom, because this carbon atom seems to be electrophilic in nature, and when this form as a bond, but in this case there will be no formation of the carbocation. In this case here, the resulting species is obtained, that species is known as a enol. Remember, what do you mean by the enol? Here let us see HC double bond C, one hydrogen atom originally present on this carbon atom and one additional hydrogen atom attached here, so it becomes as a CH2 and here becomes as a OH here, right? This type of the hydroxy group attached near to the carbon-carbon double bond, that species is known as a enol, and this one is known as a enol. Remember, enol, enolate, or what we can call it as a epoxide. These are the word frequently we are using while studying this course. So remember, what does it mean? Enol means what? Enolate means what? Or epoxide means what? Epoxide, you know that there is a 3-membered ring, cyclic ether, that type of the species is known as epoxide. And then enolate, enolate means what? The oxygen atom carrying the negative charge adjacent, there is a carbon-carbon double bond, that type of the species, and that you will see in the next coming, what is that, aldol condensation reaction, that time we will see that species enolate. But enol means what? Enol means what? Hydroxyl group attached to the carbon-carbon double bond, that organic species is known as a enol, and that enol goes in the tautomerism, and that tautomerism, as we know that tautomerism means what, or tautomers means what? Tautomerism means what? When two interconvertible structure coexist at an equilibrium, that process is known as a tautomerism, and that phenomenon is known as a tautomerism, and that isomer is known as a tautomers, and therefore, and it is always shown by this arrow, right? This is a equilibrium arrow, or what we can call it as a tautomerism, and in the at an equilibrium, what is going to happen here? This one of the hydrogen atom is moving or distributed like this, forming here this hydrogen is transferred, or what we can call it as a distributed internally, and it reaches to this side. So what do you get? The structure, one hydrogen atom over there, and this is a double bond with that oxygen atom, and now here becomes as a CH3. Look at this structure carefully, observe this structure. What do you see over here? This structure is nothing but our acetaldehyde. Look at here, and now at an equilibrium, the equilibrium shifted toward the keto form, and this is called as a enol form, this one is called as a keto form, and these two structures are tautomers of each other. They are present, and here it may be present at only as a 7%, it may be as a 93%. Keto form is a major because the equilibrium shifted toward the right hand side, means keto form is a major in this case. So this is the what we can call it as a mechanism, as well as the somewhat explanation regarding as a addition of water, and H2SO4 and HgSO4, it acts as just as a catalyst. They get regenerated, and we are getting as a this type of the compound. Understood this one? They here just they are playing as a role of catalyst over there, and as we know that catalyst, they lower the energy of activation, and the rate of reaction is increased, or they speed up the reaction. So that is the main role they are playing in this reaction. Now let us see the another example where we can see how we will get as a this type of the reaction. Let us see another example, second example here. Look at here, CH3, C triple bond, CH, and that will be treated with H2O, and now I know now you are able to predict the product, right? Now predict the product. Why you are able to predict the product? Because you know the mechanism now, and as we know that if you know the mechanism, you can able to predict the product. It's so they are predicting product if you are knowing the mechanism. Now let us look at here H2SO4, sulfuric acid in presence of HgSO4, mercuric sulfate, and now what you are going to get, what product you are going to predict here? Let us see here. Tell me, what is the name of this compound? The name of this starting compound is a 1, 2, 3. That is a 3 carbon atom in the straight chain, and therefore propyne. This is the structure of propyne. Last suffix Y and E clearly indicate that there is a carbon-carbon triple bond is present. This is a terminal alkyne that we will see shortly, but here this is the structure of propyne, IUPACS name of this compound. And now what will be the product over here? The product you are going to get here, C double bond O, CH3. Do you know the name of this structure? Many times you are using in the laboratory the name of this compound. It is famous by its common name. The common name of this compound is acetophenone. That is acetone. The common name of this compound is acetone, and while cleaning or removing as nail polish, it is used as acetone over there. So it is one of the very good organic solvent. Volatile solvents are there, and while carrying out different type of the reaction in the laboratory, we can use as a solvent. It is a acetone. Can you tell me the IUPACS name of this compound? Yes. Select the longest continuous chain 1, 2, 3, that carbonyl group exactly present in the middle one. And as I already told you that only acetylene gives you the aldehyde, acetaldehyde, and rest of the alkyne gives the ketone, and this is the ketone RC, and as we know that aldehyde are the compound having has the general formula RCHOH, right? And always remember, aldehyde group is always present at the end of the carbon chain. Similarly, acetone or the ketone are the compound containing RC+R group, and where R and R dash may be aliphatic or aromatic, and as we know that aliphatic means what, aromatic means what, aromatic compound which fulfill the following criteria, like it is a cyclic in nature, fully conjugated, planar, obeys or follows 4n plus 2 pi electron system. That type of the compound is called as the aromatic compound, and the rest of the compound are the aliphatic compound. And now here, can you tell me the IUPACS name of this compound? The IUPACS name of this compound is a 2-propanone. The IUPACS name of this compound is a 2-propanone. At 2 position there is a carbonyl group present over there, and therefore the name of this compound is a 2-propanone. Understood this? Now let us look at the mechanism, how we are getting, because I am knowing the mechanism, you also know that, because just now we have seen the mechanism, and that's why we are predicting this product. Now let us see that mechanism again. Let us see here. Write down this one, CH3, C triple bond, CH, right? As we know that water we can write as a mechanism point of view, we can write like this, and as we know that it get that hydrogen atom get plus delta charge, whereas OH hydroxy will get the minus delta charge. And as we know that how to show the mechanism arrow, this is act as a nucleophile, and as we know that nucleophile means what, electron rich species, and electron rich species always attacking on the electrophile. Now it is a electron negative species, and this electron negative species is going to attack at this carbon atom, because here this carbon center becomes as a electrophilic in nature, and the resulting compound we are going to get here CH3, then C, look at here, still double bond, one of the pi bond forming the sigma bond with that hydrogen atom, still there is a 2 pi bond remains, 2 bonds remains there, they are as it is, and here joining as a hydroxy group, and here one hydrogen, original hydrogen actually connected, and one is from this hydroxy group, and therefore it becomes as a CH2, right? And now this species, as we know, what is this species? This species is known as a enol. Enol means what? Hydroxy group attached to the carbon-carbon double bond is known as a enol, and that's why enol. And as we know that enol, they are the tautomerism when two interconvertible compound coexist at an equilibrium, that phenomenon is known as a tautomerism, and tautomerism like as a enol form or the keto form. And now it is going to convert into this form as a double bond over there, and here hydrogen atom, and you will be getting here CH3, C double bond O, and the CH3, that is the acetone. And look at this above structure, above, and this one remains as a same in this case, and in this way we can see there is a acetone atoms over here. Look at, this is the mechanism. Now you tell me whether you able to predict this product or not, because let us see here another example, CH3, then C triple bond C, then CH3, that will be treated with H2O in presence of H2SO4 and HgSO4. Predict the product. Now your turn. So predict the product and tell me what type of the product do you get here. Any guess? Yes, because there is a carbon-carbon triple bonds are there. This is a hydration reaction. Hydration means what? Addition of water over there, and the resulting compound you are going to get as a formation of the ketone over there, right? And here carbon-carbon triple bond, so that you will get either introduce that carbonyl group here or here, right? That's it. So that you will get the product. This one CH3, C double bond O, then CH2 and CH3. This type of the product you will get. If you write as a mechanism, you will get as a this type of the product in this case. And now look at, can you tell me what is the IUPACS name of this starting material? Yes, most of you might be knowing. So look at 1, 2, 3 and 4. 4 carbon atom in the straight chain. At 2 position there is a carbon-carbon triple bond, and therefore the IUPACS name of this compound is a 2-butyne, right? 2, but indicate as a 4 carbon atom in the straight chain, and last suffix YNE indicate as a triple bond present in this carbon compound. And now look at here, 1, 2, 3, 4. Numbering should be start from this side, from the left hand side, because the carbonyl group is nearest to this. When you number from the left side, so you will find the carbonyl group nearest to this this side, and if you start from this side, that is far away from, and therefore the proper way of numbering should be start from the left hand side, and that's why the carbonyl group present at 2 position, 4 carbon atom in the straight chain. So you can give 2 butanoic, 2 butanone. Last suffix ONE indicate replaced by the ONE. So 2 butanone. Either you can write like this, or you can write butane 2 ONE. Either this way or this way, both are the correct way of giving the IUPACS name of this compound. I think with this you might be clear with the mechanism. If any what we can call it as a number of example we can take here, and we can predict the product once you know the basic. If you pay the attention from the beginning, you will understood everything how to predict that product. So that is the thing over here. Now let us look at, let us move on to the next point in this carbon-carbon triple bond. The what is that formation of the acetanalides. That is a point we are going to discuss over here. Formation of the acetanalide, formation of the metal acetanalide, formation of metal acetanalide, formation of metal acetylide, formation of metal acetylide. This is one of the last point remaining of this carbon-carbon triple bond reaction that we are learning here, right? Only terminal. Now remember, only terminal alkynes. Do you remember formation of the metal acetylide? The criteria for the formation of the metal acetylide, this can be formed when there is a terminal alkyne is present. Remember, terminal alkyne means what? Suppose you have R C triple bond C H. This is called as a terminal alkyne. This one is called as a terminal alkyne. Terminal alkyne. This is a terminal alkyne, means at the end there should be hydrogen atom. That type of the species are called as a terminal alkyne. Suppose our examples are here, terminal alkyne. Here you can put R is equal to H, C triple bond C, here also H. This is a terminal alkyne. Or H you can write CH3, C triple bond CH. Look at the terminal side over there. You can see CH3, CH2, C triple bond C. Go on changing. But remember the end or the end of the chain means that that are the species called as a terminal alkyne. And now the word non-terminal, non-terminal over there. Let us see the example of non-terminal. Suppose you have R, C triple bond C, R. This is called as a non-terminal. Non-terminal. Terminal. Non-terminal. Non-terminal alkyne. This is a non-terminal alkyne. What does it mean? Here R and R, there should be as a alkyl. Don't take as a hydrogen. If you take as a hydrogen, you will get this terminal alkyne. So remember, here always put as a methyl group, alkyl group, aromatic group, anything you can put here, but put that one, alkyl one, CH3, triple bond C or CH3. Remember, if these compounds are there, the formation of the metal acetanilide, when it is possible, if there is a terminal alkynes are present. If non-terminal alkynes are present, there is a no formation of formation of metal acetanilide. Metal acetylides. If non-terminal alkynes are present, there will be a no formation of the metal acetanilide. Never form. That if non-terminal alkynes are present, for example this one, 2 butynes are there, or we can write CH3, CH2, C triple bond C, CH3. This is also as a non-terminal, and therefore they will not form the metal acetylides over there. Remember, and the metal generally we are using here like as a lithium or Li plus, Ag plus or Na plus or Mg2 plus. This type of the metals generally we are going to employ it over here, and the form that acetylide is known as the formation of the metal acetylide. Remember the metals like as a lithium, Li plus, Mg, and where from they are coming, they can form as a acetanilide over there. And why it is why we are learning this? Why it is important one? The application, it is a very important as far as the synthetic organic point of view is concerned. By using this approach, it is one of the excellent route to the importance of the formation of the organometallic compound, and that's why it is very important one as what we can call it as an organic point of view is concerned. For example, suppose we have a general reaction we are looking here, R C triple bond CH over there, and why this metal acetanilide is formed? Due to the presence of highly acidic proton, and we already explained why it is a highly acidic in nature, because this hydrogen atom attached to this carbon atom is a sp hybridization, and due to that carbon-carbon triple bond, shorter bond lengths are there, and that hydrogen atom is deprotected over there, and that's why it can get easily obstructed by the strong bases and form the resulting species. Sort of that is known as a metal acetanilides are there. Suppose let us see as a AgNO3, right? Silver nitrate, and it can be get R triple bond C, then Ag. As we know that metal are in a positive and here is a negative charge are there, and this is called as a silver acetylide. And or suppose if you treat with this maybe as a lithium amide, LiNH2, what do you get? You are going to R triple bond C minus charge over there. There is a positive charge, that is a lithium acetanilide. Or if you use here as a sodium amide, NaNH2 is called as a sodium amide, and what it can form? It can form R triple bond C. Here is a minus charge, here is a positive charge, that is a sodium acetanilide. And if you use as a Grignard's reagent like as a CH3 MgBr, what do you get? R C triple bond C, here is a minus charge, then MgBr here we are going to get. That type of the acetylene, magnesium bromide, that type of the aceton halides are formed. And why they are useful? If this compound aceton halide further treated application, now application for this is a application. What are the application over here? If this aceton halide is treated with a primary alkyl halide, remember primary alkyl halide, suppose as we know that RUHC, what is happening in this alkyl halide? As we know that it is a polar compound, right? Why the polarity induced in that? Because halogen atoms are more electronegative in nature, and that's why that molecule becomes as a polar in nature. This R group get as a get plus delta charge, and that X should get as a minus delta. Now look at, here is a negative and here is a positive. There is a formation of new carbon-carbon bond. New carbon-carbon bond, and that is synthetically useful, and that's why it is a application over there. And what do you get here? RC triple bond CR, means we are getting the higher alkyne, and by higher alkyne, if it is treated with the hydration, you will get as a ketone, and ketone further treated with sodium borohydride or lithium borohydride, that get reduced. And so in that way, the functional group interconversion, that type of the chapter you already learned in your previous classes, I think in SY/BSc, that type of the conversion, and that is one of the useful application of this compound, right? Now let us look at as a actual example over there. Suppose I am writing here, let us see some of the example. You quickly predict that one. Here is a CH3, then CH2, C triple bond CH. I am treating with this sodium amide NH2, and now predict the product. And suppose I have this one CH3, C triple bond CH. I am treating with this one Grignard's reagent CH3, then MgBr. What will be the product? Hydrolysis over or just you can write as this one. And now what do you get? Now look at here, this is a terminal one. You are going to get here CH3, CH2, then C triple bond C, and here the sodium. Here is a positive, here is a negative charge. Suppose how will you convert the here, suppose as a 2 ketone by using this route. So it is a very easy to find out that one. So CH3, CH2, C triple bond C. Here what do you get? Here CH3. Here is a minus charge. Here is, this will pick up the proton from here. It will get as a this methane molecule. And as we know that it is in the gaseous form that goes in the atmosphere, and this specifically the property of this aceton halide, they are insoluble in water. Remember that turbidity while carrying the experiment in the laboratory, we are getting as a halide are insoluble in water. So similarly here we are going to get, here is a CH3, C triple bond C, then MgBr. Here is a minus charge, here will be the positive charge. If you treat with this what we can call it CH3Br, methyl bromide, what do you get? You can prepare CH3, C triple bond C, then CH3. That type of the 2-butane we can easily synthesize. Means from lower alkyne we can prepare as a higher alkyne. That is a synthetic application of this. I think with this we have covered all the reaction of carbon-carbon triple bond. Tomorrow's lecture we will learn about the carbon-carbon oxygen bond, means carbonyl compounds reaction. We are going to learn introduction about this. I think with this, let us stop today here. Thank you. Have a nice day.